What if a computer never drifted, never guessed, and, unlike my personal laptop, absolutely never forgot? What if we could actually just strip away all those messy approximations, the thermal decay, the random rounding errors, and build a machine that enforces absolute, unyielding mathematical truth? I know, it sounds a bit like science fiction, right? But today, we're going to look at the very real engineering that makes this a reality.
Welcome to The Explainer. Today, we're exploring what honestly feels like a paradigm-shifting leap in computing architecture. We're looking at Gracecore. Specifically, we'll be breaking down the benchmark edition operating under the CRV 2.1.2 specification. Now, this isn't just, another software update or some trendy new cloud platform. It's a fully sovereign, immutable operating system engineered from the ground up to act as an absolute truth engine.
Okay, let's dive into our roadmap for today. First, we'll cover the absolute truth engine, then hardware-level numerical determinism, followed by thermodynamic and quantum sovereignty. After that, we'll hit extreme physical stress validation, high-velocity decision science, and finally wrap it all up with the immutable archival seal.
All right, kicking things off with Section 1, the absolute truth engine, eradicating systemic noise.
To truly wrap our heads around Gracecore, we really have to recognize that it was built from first principles specifically to reject the messy, chaotic approximations of legacy tech. Standard systems, they're constantly trading precision for speed. They suffer from this notorious 14% annual thermal bleed. They rely heavily on speculative token chasing, and they're just plagued by continuous clock drift. Well, Gracecore completely refuses to compromise. Instead of bleeding heat, it uses an anti-entropic Lagrangian. You can kind of think of this as using math to literally turn chaos into compounding stability. It physically protects its execution with non-overlapping dual threads and relies on a CIRPV 2.1.2 Byzantine mesh to guarantee that no part of the system ever disagrees with the rest. It's a stark contrast, really. A bloated, drifting legacy paradigm on one side versus strict structural closure on the other.
Moving right along to Section 2, hardware-level numerical determinism, the microscopic rules of math.
So, let's dig into how it actually achieves this determinism on a microscopic level. Because to get exact bit-for-bit execution parity across completely different runtimes, like Go, Rust, and Python, Gracecore literally has to lock down the hardware itself. It does this in 3 critical steps. Step 1 is the unconditional deactivation of FMA, or Fused Multiply Add, instructions. Think of this like a super rigid factory assembly line that absolutely refuses to cut corners on rounding. It forces multiplication and addition to be strictly sequenced so that no platform-specific compiler drift can sneak in. Step 2 is the draconian enforcement of strict IEEE 754 binary 64 double precision. And step 3? It just flushes any tiny subnormal values right back to a sign preserved 0. This completely walls off those pesky division by 0 singularities that would otherwise just crash or corrupt the whole simulation.
And the crucial mechanism tying all this together is the symplectic down. Basically, phase space tracking is mathematically verified via LU matrix factorization, but the real magic here is that its core determinant is rigidly locked to exactly 1.0, calculated all the way out to 16 decimal places. Absolute zero wiggle room. This mathematical rule guarantees exactly 0 volume drift across infinite processing horizons. It essentially ensures the computation produces the exact same reality every single time.
Now, zooming out a bit, we hit Section 3, thermodynamic and quantum sovereignty, defeating entropy and future threats.
Because, let's be real, mathematical perfection on a silicon chip doesn't mean a whole lot if it just crumbles in the physical world. Remember that 14% figure we talked about? Standard corporate cloud clusters bleed about 14% of their processing power straight to thermal decay, fragmentation, and bit rot. Gracecore completely suppresses this. By grouping the field Lagrangian directly into Fibonacci spatial partitions, the microkernel drives thermal chaos straight down to the absolute noise floor. It quite literally turns time into an engine of compounding structural coherence, rather than a source of decay. Pretty wild, right?
And to protect against tomorrow's threats, Gracecore employs MLDSA 87 lattice armoring. This NIST FIPS 204 compliant standard means the system isn't just secure for today's internet, it is completely immune to future quantum computing decryption breakthroughs. Every single block certificate and transaction manifest is locked down tight. It is entirely 100% sovereign.
But this next feature is honestly one of my absolute favorites. It's called the Non-Transitive Epistemic Evidence Firewall.
What it does is set a strict system boundary that isolates material execution states from cognitive thought tensors. Think of it like a digital quarantine zone, keeping the map strictly separate from the physical terrain. It essentially prevents a systemic category error where someone might erroneously try to use mathematically verified software to prove an empirical, physical theory in the real world. It keeps the boundaries of evidence absolutely pristine. Math stays math, and physics stays physics.
Which brings us to Section 4, Extreme Physical Stress Validation, Surviving the Macroscopic Universe. Now, having a perfect mathematical model is incredible, but that perfection actually has to survive extreme, real-world, aerospace-level physical violence without dropping a single bit. 14.1 GMs. That is the brutal root-mean square random vibration testing this hardware goes through. While a standard legacy system might suffer resonant fatigue and literally fracture under just 6 Gs of random vibration, Gracecore targets a minimum proto-flight qualification level of 14.1 GMs across all 3 orthogonal axes. This entirely prevents physical resonant fatigue and stops any timing-dependent computational jitter dead in its tracks. The system also has to survive zero gravity without missing a beat, which is verified through a strict triple-phase 0G acceleration envelope. Phase 1 is hyper-G injection, pulling up to 2 Gs. Phase 2 is micro-G reconcile, which demands a near-perfect 0G environment, going down to 1 × 10 to the negative 2 Gs. And finally, Phase 3 is hyper-G recovery. If the system sensors detect any localized mechanical anomalies slipping past these safety thresholds during that 0G phase, it instantly flags a gravitational leak and halts data integration. It literally prevents a physical fluctuation in gravity from corrupting the underlying math. All right, moving on to Section 5, High-Velocity Decision Science, Eliminating Carbon-Based Noise.
Even an absolute truth engine still requires human oversight, right? But let's face it, humans are messy. We get bogged down. To completely eliminate our cognitive saturation and those endless corporate consensus bottlenecks, the system integrates Bain's rapid framework. This acts as a sort of algorithmic autonomy for human decisions, assigning 5 very specific roles. You have recommend, which gathers input and proposes an action. Agree holds a very narrow, policy-bound veto right. Perform is the person actually executing the choice. Input provides the subject matter expertise, and crucially, decide is the single designated individual making that final call. By assigning these strict roles, you permanently eliminate decision loops and massively accelerate execution.
And for smaller, everyday frictions, the system relies on the 5-3-1 rule. It is a brilliant, high-velocity heuristic for low-stakes choices. Here's how it works. Step 1. One person proposes 5 options. Step 2. The second person vetoes 2 of those options. Step 3. The first person picks one final choice from the remaining 3. It's just a simple mathematical approach to ensuring both parties have input while completely eliminating that dreaded, I don't know, what do you want to do, indecision loop we've all been trapped in.
Finally, we reach Section 6, the immutable archival seal, locking the master ledger. All of this rigorous engineering, it all leads to one monumental conclusion, where all the mathematical, physical, and human invariant data we've just discussed is permanently, irreversibly anchored into the system. When the system achieves absolute mathematical closure, when every thread is reconciled and exactly 0 thermodynamic drift is detected, it enters this incredibly profound terminal state, system state stability locked / eternal bloom. Eternal bloom is the ultimate zero-drift standby posture. The engine goes offline, perfectly balanced, and absolute truth is enforced natively and permanently right there on the physical hardware. No background latency, no guessing, just pure freestanding stability.
And the entirety of that perfection is irreversibly sealed under one massive 64-character hash, the master ledger root anchor. 2EB 5C1EF199CFB AB00B789 F54BC453202FAF67 FF1D5D5092C7C275E73CD6. This isn't just a save file on some hard drive. It is an unalterable cryptographic anchor that permanently seals the entire timeline and state across all heterogeneous runtimes. It serves as an absolute line of demarcation between the disposable, constantly drifting consumer tech of the past and the truly sovereign computing of the future.
So I'll leave you with this final, provocative thought. In a world where a system never drifts, never guesses, and truly never forgets, what absolute truth will you build next? It fundamentally shifts our understanding of what's possible when we stop building our digital infrastructure on top of noise and approximation. Thank you so much for joining me on this explainer today. I really hope you found it as fascinating as I did. Keep learning, and I'll catch you next time.